Hello, Alex Sager here. So for the solar oven project, took it on myself and my team to take on the parabolic umbrella. So here's a diagram of it. Oops, there it is. So what it is basically had an umbrella with the handle. I kept it long at first. I'll tell you why. So the first part, I lined the inside of the umbrella with foil, a little bit of glue, and a little bit of tape to patch up some stuff, but got through that. And then, so I kept it long so that I could basically just keep the pot of water that I was trying to boil with the solar oven farther away, because I was curious to see whether or not proximity had any effect on the experiment, and it did. And I'll show you my information here. I started just about before my meeting with David, about 10 o'clock. This is the distant diagram. So it did spill, but I got it to go again, and then bubbles began to show up, and eventually I got it to boil. Just about an hour. It was sitting on there a little bit because I had my meeting at 11 with David. So then I took the handle off, and I decided I was going to put the pot of water, a fresh one, started at room temperature, and put it closer to the center of the parabola. It looked a little bit like that. I know it's a poor drawing, but it did get bubbling. That got boiling actually at about 51 minutes. Checked probably 10 to 15 minutes before. I mean, it was hot, but it wasn't boiling. And about 51 minutes, I checked again. It was definitely boiling water. So closer design, proximity obviously had an effect on the heat, and it shows that the parabolic solar oven was effective. And I also drew a graph here to kind of depict that case. Slow increase until boil. Boiling point's 212 degrees Fahrenheit. So as time increases, the temperature also increases. In about half an hour, I mean, it's still increasing. I did notice that the water was getting hot, but closer to an hour, it was definitely boiling. So that's my project. And actually, I just finished putting it away, and I had to use this plastic square thing, and it worked as kind of a case for the water. And this thing started out fresh. I didn't need it anymore, and it was just a square plastic thing with a hole in the middle, and this thing is completely obliterated from the heat. Obviously, I know that probably the metal in the pot did some of this, but I mean, it didn't do all of it. The sun had a strong effect on this. So yeah, that's my project.
Okay, my name is Sulaiman. This is project 1. I'm about to build a box cooker. And the items I have with me here is a pizza box. I have the tape, scissors, foil, and a wrapper. Okay, I will keep videoing as the project continues. Okay, after leaving the steak under the sun for hours, it's kind of started cooking. I mean, you can't just see the steam, but if you look close, you can see the steam coming up. It's still not ready yet, but in hours it should be ready either to be eaten or for every other thing. Okay, that's all.
Hi, this is Mazen. To begin the video, I'm outside right now. I just set up my apparatus for the first project, and I'm doing the parabola part of the project. And for this one, here I'll show you what I've done. For this one, I used a car sunshade, and it was I found it to be the easiest one out of the whole thing, out of all the other ones. So that's why I picked that one. And basically, you just have to fold it, and you have to be sure you can either stitch or tape the top or the bottom to keep it in its form. And what they did is they had Velcro to be sure that the pot would stay. But I set the parabola or the project on a chair that would slant, so I wouldn't have to do that. So yeah, I didn't do the Velcro thing. I didn't deem it necessary. And basically, you would have to get a black pot and fill it with water and put it in a plastic baggie. And you could choose whether or not to put it on a grill. And oops, sorry. You didn't have to really put it on a grill. So yeah. So in an hour or less, the water should boil, and then I will finish up the video summary of what's going on and all that. So just a quick look. Here's the pot and the sunshade. The tape I used. Yeah, I know it's just tape. It's good. And the sunshade. And where I'm sitting, I originally had the chair placed around to the right, around here, but I noticed that the house is blocking the sun, so now this is directly hitting the sun, and it should work, so we'll see.
When I first learned that part of this Physics 112 class was building a solar oven, I thought it was a pretty good idea, because actually our family has been considering purchasing one over the last 6 months or so, after borrowing a friend's oven and seeing what a great utility they are to have around the house, and all the different things that you can make in them. So again, when I saw that we were supposed to build one, I thought, okay, I'm going to build something that hopefully suffices for the class requirements, as well as something that the family can use after the class is over to cook in. So I started with researching on the internet, came across a site called builditsolar.com that had a number of different designs, sketches, some instructions on some. Anyway, I settled on what you see here in front of you. Looks a little crude at this point, and we'll get to that in a minute, but basically what came off the internet is a copy of the plans, and it's basically a front and a back, a couple sides, and a bottom, and a glass top that will go over the top of it. So if we can review the design here real quick, again, it's just a basic box, 1/2-inch plywood. I put some brackets here to hold the solar reflectors, which I'll show you in just a second. I also built it to where the back of the oven opens, and my initial idea was this is how someone would open the oven to take whatever is being cooked in and out. After messing around with it a little bit yesterday, I'm seeing that this isn't necessarily the best way to do that. And the problem is that and I don't know if you guys have seen this also when you're messing around with your solar ovens, but you have to kind of be able to tilt it this way or this way to get the sun's rays to focus as much as you can on the inside of the box. So the problem with it is if you've got something in there that's cooking and you can't tilt it too far, because otherwise whatever it is could spill all over the inside of the oven. So long story short, what I'm going to do is I'm going to make the glass top removable or hingeable, and then I also need to put some kind of like cradling device inside there so that when something cooks it can kind of almost swing this way or that way just to keep perpendicular with the ground. Let's see, so basically followed the plans, made the cuts, put it together, used a black spray paint on the interior, and I chose to use it's actually grill paint, so it's supposed to be good for high temperatures, so hopefully it won't give toxic stuff off and kill everybody in the family. So part of it also is obviously the reflector portion, and built these in such a way so that they fold up, easier storage, and then of course when you need them they fold out. Okay, and these need to go on like this type of thing. You can see it's still a little bit of a work in progress. Now, as I had mentioned, there's a glass top that's supposed to go on there. Well, I think it's best to use tempered glass, which is kind of a safety glass, so if it does shatter, it shatters in smaller, less jagged pieces, as well as it's also capable of withstanding quite a bit more heat than normal glass. Well, the problem with it is a week or so ago, when I placed the order, I went on Thursday to pick up the piece of glass. They screwed up the size. So I won't have the final glass for the project until they're telling me now Tuesday or Wednesday of this week, which is beyond our deadline to get this thing working. So in the interim, what I did yesterday, in an attempt to try to find something that was clear to put over it, I went with good old cling wrap, and I had the oven set up as you currently see it. I put the cling wrap over the top of the oven, double sheets, and obviously a lot of the heat was able to escape, but I could still see that it was working quite well. What I did was, after I had the cling wrap put on there, I do have a multimeter that has a thermocouple input on it. So I had this little guy installed in the oven, and at about 4:30 in the afternoon, because I actually didn't get it built and the thermocouple in there until about 4 o'clock, but at about 4:30, maybe 4:45, the highest the oven was able to get yesterday was 190, which is a little shy of being able to bubble water, but I'm pretty confident that during the heat of the day, as well as once I get the glass top on there, that I ought to be able to get, I'm hoping at least 250. And basically the science, technology behind it is that, from my learning, the sun's rays, obviously there's a visual light spectrum that we're all aware of, as well as there's ultraviolet that's coming from the sun, there's UV that's coming from the sun. I might be stretching it here, but I believe that there's also microwave that comes from the sun. But anyway, what we're really interested in is that visual light pattern as far as the solar cooker is concerned, because another thing that I did learn is that once you put that sheet of glass on there, only visible light will end up transferring through the glass. The UV, I believe some of that will, but for the most part it's only the visible light that gets through the glass. So once that visible light hits the reflectors, as the term implies, that light is reflected and concentrated into the box. The reason that you want the box painted black on the interior is that once that visible light hits that black, it cannot reflect, it cannot refract if it's, you know, perfectly flat black. And all of that light energy then is transferred into heat energy. So that's what the black basically does for us. It transfers light energy into heat energy, which is what we want to cook food. Again, I apologize that I don't have a graph done at this point, but the glass supplier kind of messed me up on that. But I did see, like I said, about 190, 192 I think was the actual, and hoping to see much better once I get the glass on. Thank you.